Hey, hello, everybody. Just setting things up here. Really excited about the live workshop today. Hope you all are, people I think are starting to join. I see like about 50 or so users here and there. Uh, yeah, so let's give people just a minute, Saad, and then we can start looking at what we are going to be talking about today, right? So I am probably looking at my data here from our example. Did you check the example I sent you just this morning?
Yeah, I looked at it. The README was really helpful.
Oh, okay, awesome. So should we go with that, or do you have something handy? I think a simple example like that should be fine. Building memory agents with Agentic RAG and TypeScript.
Yeah, sounds good. Like, yeah, we can definitely use that example.
Okie dokie. Let me see if I can open up this doc, and probably let's give people just a minute. Uh, there you go. I think we have enough people. Did you send out the email blast to everybody on Luma?
Yeah, I am doing it right now. In fact, yeah,
Yeah, probably just send everybody the direct link to the YouTube, right? So
yeah.
okay, so everybody here, I am hopeful that you got my previous email just about 80 or so minutes ago. The prerequisites for this workshop is that you have an account on Langbase and you have at least added one LLM API key. Since we are going to be using OpenAI in this workshop, so make sure you have your OpenAI LLM key in your Langbase AI Studio. And just to quickly walk over what that looks like, Saad, you want to mute yourself when you're typing? I can hear all of it.
Oh, yeah, sure.
Awesome. Okay, so just quickly gonna share this screen, and yeah, there we have it, right? So first of all, you wanna go, head over to langbase.com/sign up, sign up, right? And this should direct you to, sign up with, any of the services you like. And you'll probably land here in our studio, langbase.com/studio. This is where, we are going to do a lot of stuff, right? You are probably going to head over to settings. So just quickly a wrap up. So we are going to be using Langbase SDK to send a lot of requests here and there. And this SDK is meant for people who love using TypeScript, JavaScript, Node.js, all of that fun stuff, right? And so for this you need your Langbase or user or org API key. So once you're logged in, you can either create an org account here, or you can just use your current user account here. And you go to your settings page, you go to your Langbase API keys, and you generate one, right? So you can generate any kind of API key here. You click here, you name it, and give it a description or whatnot, and just copy it and keep it handy, right? Because we are going to be using it. And the second thing you are going to do is you are going to head over to settings again, and you're going to click LLM API keys. In LLM API keys, these are all the LLM large language model providers, right? And you can use any of those. But for this workshop, we are going to be using OpenAI. Once you open this, you will see this handy little link over here. So you can just click it. It'll redirect you to your platform, platform.api, openai.com, the API keys section. If not, probably log in, go to dashboard, come to your API keys section, and just create a new key. You can create a new key, name it whatever, maybe give it all the permissions. But what we are going to probably use this key for is to generate responses, chat completions, and embeddings, right? If you want to restrict control or whatnot, right? And then you copy it and you put it back here, save it. So this is ready in your account, right? And if you are in an organization, let's say I move to Langbase organization, right? The same thing applies, right? So same LLM API keys here and Langbase API keys here, right? I'm gonna move back to my personal account just so that we are almost ready, right? Okay. What else? I think what I can do is I can probably copy over the README I was writing to the README here for this agent that we are going to be building today. Okay, let me come over here, put this here. There you go, right? So this is what's going to be happening today, right? We are going to be building a memory agent, Agentic RAG in TypeScript. And we're going to go over every little detail here, how RAG works, why should you use it, what is Agentic RAG or whatnot. And all of the code is going to be there. This live stream is being recorded, so you don't need to worry about a lot of things here. And everything about this should be pretty easy and handy, right? Okay, now looking at all of the data here, let's start with something very, very simple, right? Let's start with what is happening here, right? We are going to be building a memory agent. We are going to be using Langbase for all of this. So we will create a memory to store your documentation. We will upload some data in that memory. We will retrieve a query related to which we will see, if there are chunks that we are getting. And then we will create an agent to process all of this, and we will generate a response based on top of this. Yeah, right now it sounds like a lot of steps, but in just a minute it should be pretty handy and easy to understand. Right off the bat here, Saad, do you have any comments before we jump into the workshop or whatnot? Like, maybe do you think we should probably be talking about something else, or starting with the basic bare bones? Let me know.
Yeah, I think maybe we should probably like just give a quick idea about how memory agents are going to be working along with the pipe. And yeah, that would be awesome.
Okay, let me see what we can do here. Let's start with an intro of sorts here. What do you say?
Yeah, sounds
Uh,
good.
go ahead and introduce yourself while I figure out my slides over here.
Yeah, sure. So, to those of you who are watching, I am Saad Irfan. I am a founding engineer here at Langbase, and yeah, I work with everything there is to work with. If you are using Langbase, then you would probably use some of the you have probably used some of the things that I have developed. And right now, like we are like a lot of like we have seen a lot of requests from people in our Discord channel. By the way, if you are not part of our Discord, go ahead, join it right away. Like you can go to langbase.com/discord and you can be a part of it. So in our Discord, we saw a lot of requests around like memory agents, how to use them, how to use them with TypeScript. So since like we already even provide an API, we in TypeScript, we have an our native SDK that you can use. And with that SDK, you can easily build memory agents and probably like get them up and running in like less than 10 minutes. I am 10 minutes is a stretch, I would say. So yeah, that's what we are up to. That's why we are doing this simple workshop. And yeah, and I think you have your slides up, right?
Yeah, awesome. Let's get into this, right? Let's get into the weeds of everything, right? What we are building here are serverless AI agents, and we are going to be using AI native primitives that you can use to become an AI engineer, right? So just a quick overview of what's happening here. I am Ahmad Awais. I'm the founder and CEO of Langbase. I spent like I don't know 2 decades building this and that, everything from being part of the original Whatware group where I used to contribute to the HTML5 spec to a career in open source where I built so many things: the core software of WordPress, the core software behind React.js, Node.js, Next.js, core contributions here and there. Even got a little bit, of my code into the NASA Mars Ingenuity mission. And then in 2020, I built Corona CLI, which was like Perplexity for COVID data. And you could ask it fun stuff like, I don't know, if I go pick up TP from Costco, will I die? It went absolutely viral. Ended up getting an invite to OpenAI GPT-3 through Sam Altman and Greg Brookman in 2020. GPT-3 was like about a month old, and I think I've sent my first request in rest is history. Since then, I've been completely obsessed with building agents. And I ended up doing so much on the side that so much became Langbase. And excited to show you what it looks like. So okay, I probably went over all of these slides. I was traveling a lot, and then COVID happened. Greg gave me the key, and I started building. He asked me like, what are you gonna do with this, right? And I was like, I want to suggest next line of code with this. And I remind you, this is like about a year before there was GitHub Copilot, right? So the space was pretty novel and nascent at that time, right? So Langbase is your developer platform, a complete full spectrum end-to-end platform where we help you both build, deploy, and scale AI agents. And this is what I think is unique. Whenever you are building an agent, what is an agent, right? An AI agent is sort of like an autonomous entity, right? I think everybody has a different definition of what an AI agent is, but how I like to define it is AI agent is just agents are just code, right? It's just a new type of code which has LLMs embedded in them, so they can make a lot of decisions and actions, right? So AI agents can understand what you are asking them to do. They can manage the context. They can understand the environment they are in right now. If this is a coding request and if they have the context of your current repository, or if this is a request related to a question that you have with some private internal documentation data, and if they have in that data in their context to be able to act on it, right? So agents understand what you are asking them, and then they are able to take meaningful actions, right? So help me analyze this 100-page PDF, right? If you just throw in a 100-page PDF and ask it to summarize, it will probably not do that well. You'll have to build that complete layer from the ground up using a lot of AI primitives. You'll have to chunk every page or maybe every paragraph, summarize every paragraph, and combine that into an analysis that is relevant to your space, right? To do all of this, you will have to build a lot of things. And a lot of people, basically what they do is they quickly end up choosing a framework, and then they oftentimes I read about this and I learn that they regret that choice, right? So at Langbase, what we have done is we have pioneered a no framework approach. I think frameworks do not work in this space because the ground is not solid enough. There's no solid fundamental to build a framework on top of, right? Everybody's trying to build a framework on top of different LLMs, but LLMs are always changing. Their APIs are always changing. You cannot build a framework like that, right? So we initially, we from the very beginning, we took a no framework approach. We have an API and we have an SDK to use that API. So it becomes really, really easy. And what your architecture ends up looking like is very much like this, right? So you have an LLM, and that LLM is able to maintain a thread, thread of conversations, back and forth between you and other agents. Maybe it's a multi-agent architecture, and then it is able to manage its context layer. So it knows what is in that particular context. How it's probably. Give me a minute. So mute yourself. Yeah, how it is managing that context. What is the context that it requires to probably answer the last question that you just asked. And then it has memory. Memory generally, ChatGPT has this short-term memory concept. So a lot of people think about memory as, in agent needing to know, like, what are my tastes and what are my preferences. I think that's like more like habits and not memory. Right? Memory is long-term memory. We have a primitive called memory agents, and it is very much like human memory, right? So it is long-term memory. In so memory agents on Langbase are like human memory. You can train this AI memory with your data, with your knowledge, maybe your docs, maybe your database, whatever you type of data you want to put into that particular agent, and you can just ask it questions without worrying about infrastructure, scale, vector stores, all of that fun stuff, which we just provide you with, right? So again, most of the architectures that I look at in this space when people are building agents are could potentially be simplified to something like this, right? So in LLM that is maintaining a thread context in memory, and we provide you with all of these AI primitives, and so you can compose them however you want to have, like 10 different threads going on, 10 different memory agents with terabytes of data in them. You can very easily do that with us, right? And most often than not, what I see in this space is, when you start deploying these architectures, there are always a different variant of these architectures that you end up with. So right now it looks the same, that's my skill level for building slides. But you end up with different flavors of these agents, and you end up with a lot of these. You end up with, concurrent 200 agents trying to solve a simple problem, analyzing data, trying to analyze a 100-page PDF or whatnot in a platform. Because it is serverless, it just scales to your needs without you having to do anything, right? And we scaled a lot. I'm pretty sure the stats here are outdated. We are about to hit 100 million agent runs almost every month, about 110,000 agents live on our platform, and I think about 20,000 are actually completely public. If you go to langbase.com/explore, you will be able to find, all of the public agents that you can fork and use, right? And we processed like hundreds of billions of tokens already. So I think that's enough theory. Let's get into the weeds of this workshop and start writing code, right? So to add more context, let me actually now switch back to what we are going to be doing here, right?
You know,
So
I
I'm
think
gonna,
Ahmed, you just answered why sending direct request to OpenAI probably won't work to build an agent.
yeah, you wanna take that one?
Yeah, like for example, I think like when using primitive level approach, that's how you build agents. And with Langbase, you can do that. We have so many agents as so many primitives that you can use, as Emma just described. And these primitives are essential when you're building an AI agent because they provide you with different levels of features. For example, managing threads, managing context, managing long-term memory. So all these things
Yeah.
come together to build an agent. So sending a direct request to OpenAI to build an agent probably won't work there.
Yeah, so let's start understanding what we are going to do here, right? So imagine we have some data here, and we can call it a PDF file or markdown file. And this data has something in it. Let's just call it. I go to my blog, and I'm gonna just save this entire page as a PDF, and then I'm gonna ask questions from this page, related to anything that is on this page. And then I'm gonna add some notes into my data layer about what I'm doing right now, right? So we have data, right? This is just the data piece we have, right? So then what we need is we need a memory, and this memory is where we are going to upload all of this data, right? Once we have done that, we should be able to ask questions from this memory. Like, for example, tell me about, Ahmed's latest blog post, right? And once I do that, this memory will actually go search inside of this particular data set the semantically similar data to this question, right? And then it will provide me with what is relevant, a bunch of chunks, right? So here's a chunk of text that is relevant. Here's a chunk of text that is relevant back to me. And this set of chunks is what I'm going to use, and I'm going to throw them into another agent. This agent will have an LLM inside of it. And then I'm going to throw this question again to this, right? And all of a sudden, this will end up with this, right? So if I go back to my blog, you should be able to see that I have, reissue Cloudflare SSL certificate manually as the last blog post. And this entire text will be thrown here as chunk, and this question is going to come here, and we are going to send this entire chunk, this particular chunk and the question to an LLM, right? So we will send this to an LLM, and the LLM, if you tell an LLM, like if you go and tell ChatGPT that this was the last post I wrote, and then you ask, what was the last post I wrote, it should be pretty easy for, ChatGPT or any LLM to answer that question, right? And that is the very basic of retrieval augmented generation. So we created an index of our data in the memory. So this part is the indexation, right? And then we asked a question, right? Okay. And then we asked a question from that memory. So now what's happening is this part is r- the complete retrieval, right? We are getting back the chunks, and then we are adding those chunks here. This is, let me add here chunks, and the question, the query that we are going to get here, we are augmenting those chunks and sending it to an LLM, right? So retrieval, augmentation, and this LLM is going to generate a response back generation, right? So you embed your data in a format that is easy to semantically search, so you can retrieve that data. And this data could be huge. This could be like terabytes of data. And your question, this memory agent is going to agentically find that data, the relevant data to your question, right? So retrieve the relevant chunks and then augment them, and then get an LLM to generate a response based on that. That's the very basics of this entire concept of retrieval augmented generation. I'm taking a very beginner approach in this particular workshop. So I'm explaining everything in detail. You can definitely go to our docs, and you can see all of the agent examples here. You can study how we talk about retrieval or whatnot. Even more so, you can go into concepts and you can study deeply what is RAG, how does it actually work, what is a vector store, what are the vectors and embeddings, what do they look like, and how are they able to find the relevant, semantically relevant. This is not keyword search. This is not command F and search for a keyword. This is semantic search. So the entire question semantically needs to be similar to the data. And that is how we find more relevant questions. And then there's re-ranking in it and a bunch of other stuff. You can learn more about chunking, retrieval, all of the fun stuff here, right? So I'm not going to go over all of this in deep detail, as I just explained the basics of it. And before we start, I'm going to probably share one thing, right? So how do you use Langbase, right? I would recommend that you go to our Langbase SDK and use, our SDK, or if you, for TypeScript users, right? And if you are using it with Python or any other language, you should probably go to our API reference and use our API, which works with just about any language, right? We have all sorts of primitives listed here, right? Okay, now that you know this, and now that you know pipes are the agents, pipe is the thing which we created, which connects any LLM to any data and gives you an API. So we are going to create this agent, and we are going to create a memory. Memory is where you will upload the data, you will ask your questions, and get back your answers. Let's get our hands dirty and get started with this. Again, the only last thing I'll probably mention, I completely forgot about this. If you go to our agent example sections in agent architectures, you will probably find about 8 different agentic architectures here that are most common in this space. You will see an augmented LLM, which is literally a pipe agent, which has access to tools, threads in memory. And my favorite, there are a bunch of others, but my favorite is orchestrator worker, where you create an agent that, based on an input, decides to create n number of more agents, run those n number of more agents, and then another agent that synthesizes all of that result. This is roughly basically how the deep research part in a lot of different products like Perplexity or ChatGPT work, right? And in just about 80, 90 lines of code, you can see, how that works. You can even run this and see, what the output looks like for this particular agent, right? Okay, now that you know this, all of this, let's now actually really get started with building RAG, auto RAG in an AI agent with a memory agent that is going to be doing all of the fun stuff that we just talked about. Okay, uh, for everyone, you can go to this link. I am gonna throw this link in the chat here. This is the source code of all of the workshop we are going to do here, right? So what you're going to do, you can maybe even just look at what I'm doing right now, and later on use all of this code to figure out what was done, or you can just follow along with me creating everything from absolute scratch, right? So I'm right now gonna go ahead and do this, right? So let me open up my VS code here, or maybe I can just do this here. uh, Come over here. Yeah. I should probably not be doing this here because I need to run it. I
Yeah.
completely forgot. Yeah, yeah, yeah. While I share my screen, Sa, do you have any questions?
I think like right now, no questions. But one thing to mention that while we are doing this, like we will be creating a bunch of things. We will be creating a memory. We will be uploading documents to the memory. The memory will be agentic, as you will see. And finally, we will be retrieving some chunks and sending it to an agent pipe. That will do the generation. So quick
Awesome.
overview of what we are doing.
Awesome, awesome. So let's get started, right? What is happening here? What I've done is I've thrown some docs here. So this is literally that, I cannot show you the preview of this PDF here in VS Code, but this is the I downloaded the homepage of my blog as a PDF, and I have also added a notes.md file in which I have basically written something like Ahmad and Sara doing a workshop or to build agentic RAG with TypeScript on this date, right? So this is live data, right? And every LLM struggles with this, right? I should probably zoom in a little. Yeah. Okay. Every LLM has this universal constraint that it was trained on public information, and it doesn't know anything about live real-time information or your private data, right? That's why you need to build and train a memory agent that knows how to retrieve the right things from your memory, right? Okay, so the first thing we are going to do is this. We are going to create a memory, right? And everything here, we have that in our talks. It's pretty easy to understand all of this, but right now I'm creating all of this in TypeScript, and because I'm doing this locally, I'm going to run this in Node.js. I'm also importing .env, so I should be able to read the environment variables. But if you are using something like Next.js or Hono on Cloudflare or something like that, you should basically be able to figure out where your environment variables are and throw them into this particular thing where we just need to add that Langbase API key here, right? Right now, I have this example. You can basically copy this and create a .env file and put your or key here, user Langbase user API key here, and we are off to the races after that, right? So first of all, let's create a memory, right? The very first step. We need a memory so that we can store your documents inside of it. When you create a memory on Langbase, it already has a vector store in it. You don't need to go, pick something out there. Our vector store is 30 to 50 times cheaper than most of our competition, like Pinecone or whatnot. And it scales serverlessly, right? You can create thousands of memory agents, and all those memory agents will have separate vector stores in them. So you don't need to worry about scale. That is literally what we do. You write the logic, you write the code, and we take care of the infra logistics behind the scene, right? So to create a memory, all you have to do is write a function like this. So you install Langbase, which I have already done. Pnpm install Langbase and .inf. So this will go ahead and create, packages. It should probably create a packages in file where both of these packages will be installed, right? And I think what you should also do is install uh, as a dev dependency Node.js types. This should be helpful because we are using TypeScript, and it should probably know about all the types here, like process.env or whatnot, right? Then I have created, again, two folders, a data folder, which has all of my data here, and an agent folder where I'm going to create all of the files related to the agent, right? So this is the first file, right? The first file is creating memory. I've created a basic function, and this function is where we are going to create a memory. So in this langbase.memories.create, I'm going to name this as something like rag knowledge base or whatnot. And since I've already done that, I'm probably going to do it as knowledge base demo, right? So I'm going to copy this, and this is where you're gonna store all of your docs or whatnot. It's pretty simple, right? Let's go ahead and run this. I'm going to run this with npx tsx. What this is going to do is it is going to execute a package called tsx. So you should allow it. Maybe for the first time you run it, it will probably ask for confirmation. And this package should be able to run a TypeScript file without you having to, do any sorts of fun stuff like, building a TypeScript file or whatnot, right? And the file I want to run is inside of agents folder. It is memory create file, memory create, where it is. What is happening? Create. Why is it not recommending that? Oh, I see the problem now. Give me a minute. There you go. So npx tsx agent memory, and inside of here we are going to create the memory, right? So I just ran this one, and there you go. So now that I had my user Langbase API key in the environment file, and I wrote this code to create a memory, ran that particular command, this particular script, I basically got a memory created. This is the memory. It is actually using OpenAI text embedding 3 large model. And this is just the default chunk size or whatnot. If you want to, change this, you can. And this has also been created on our, AI Studio, right? Right now, we are just going to be in the code, but probably after this, I'm going to show you what it looks like inside of our AI Studio as well, right? So first step done, we have created a memory, right? As you can see here, uh, this is the workflow, memory create. So we've created the memory. The second step is to upload, right? So let's upload the docs. And for that, I've created this particular file. And you can, there are a number of ways how you can upload documents to your, memory. But I'm just taking a simple path because we are doing this locally. All I'm going to do here is I'm going to give it the path to where the document file is. So process.current working directory. Again, forgot to tell you, uh, we are importing Langbase. Again, giving it the API key of Langbase, right? And then inside here, I want to understand where the data path is. So process.current working directory will give it the directory, the root directory, where I'm going to be running this npx tsx agent upload command, right? So this command. So this directory, root directory, and from the root directory, I'm going into this data directory and I'm giving it access to this particular file. So this is the data path. And then I'm uploading this particular file to the memory we just created, right? Okay, let's see if we can easily figure this out, because there are two things happening here. We were, if, yeah, I think that's about it, right? So we're using langbase.memories.documents.upload method. In this, I'm going to give it the name of the memory we just created in the last step, which was this one, right? So I'm going to probably do this. Yeah. So this is the memory where I want to upload my document. The document that I'm uploading, it is of application slash PDF content type, right? Is here. And I'm also adding some metadata here, right? So I'm adding a category that this is a blog. Like for later, if I wanted to only get chunks related to my blog, I should be able to filter it down with this metadata, right? And that's pretty much it. I'm gonna upload it, and I'm gonna see if this got uploaded, right? Here's a data path, and there you go. The document was uploaded in our AI Studio. The next thing I'm going to do is, which is why there were comments here, I'm also going to upload that notes.md file. And to keep this a little bit simpler, what I've done is I've not probably created a loop here or whatnot to just quickly go over. There's two files, right? You can create all sorts of loops here. You can point it to a folder and throw all of your folder with hundreds of thousands of files into a memory pretty easily, right? Okay. And Saad, if you see anything, I'm missing, you have a quick question, feel free to, ask that right away, right? So, and now I'm going to upload this particular text file, which is a markdown file. So it's a text markdown file. Notes.md is the name of this document. Same memory. And the category for this is notes. So I'm going to probably run this one more time. And there you go. So the document has been uploaded to our memory, right? And right now, what's happening behind the scene in our AI Studio, behind this API, is this, right? So it's basically in this memory, we threw a bunch of data, right? So documents, and these documents are now being chunked without you having to do anything, based on how the configuration of our memory is. And these chunks are being sent to OpenAI. OpenAI is embedding all of these chunks, right? And we are getting back the embeddings. And then from these embeddings, we are basically storing all of them into our vector store that you don't have to worry about, right? So all of this happened the moment you uploaded your files to our memory, right? And in just about a couple of minutes, all of this data is prepared in the form, in the embedded form, indexed data in a vector store, so you can quickly ask questions from that data, right? And that is literally the next step, right? So let's try and do that. The next step, as you can see in the README as well, is to retrieve. When a query is received, the system will create the embeddings of that query and compare those embeddings with the embeddings in our memory, right? This piece, I feel like I need to explain a little bit further. So I'm going to quickly share my screen where I am going to draw this out so you can easily understand what is happening, right? Let me share this screen. So there you go. So what's happening is we have done this so far. So we created a memory. So there is a memory, right? And we uploaded two data files in there, right? So we uploaded a PDF file and we uploaded a markdown file, right? An MD file, right? And I can actually go in our studio right now and quickly catch you up on what is happening behind the scene. So I'm going to my memories. This is the RAG knowledge base demo memory. And you can see the doc, PDF, and notes MD files are here, and they are ready. The status is ready means they were embedded and whatnot. What happened here is the moment you uploaded them to memory, memory went ahead, chunked each files, and then sent it to OpenAI. OpenAI created the embeddings, and these embeddings were saved in our vector index, right? And if you go to our agent examples, agent architectures, memory agent, This is actually explained here as well. So data was sent, we semantically parsed it, we chunked it, created an embedding, and stored it in an index, a vector store that lives inside of this memory agent. Now we are going to ask a question, and that question might be rewritten, and we will retrieve relevant chunks from that question, re-rank those chunks, and generate and evaluate all of that, right? So what's going to happen is now we are going to ask a question from this data, and the question could be what? Like question could be, I don't know, what is Ahmed doing today? And I'm just probably going to add the date that this is the date today. I'm going to send this question to the memory. So what's going to happen is this question is going to get embedded in it will embeddings will be created for this question. In the embeddings in our index will be compared with this embedding, right? So we will basically run a vector search, a semantic search to figure out what is relevant to this date question in our index. And I can quickly demo it to you here. Like for example, in our memory agent in our AI studio, if you go to retrieval testing and ask that very question, so what is Ahmed doing today? You will see that it will run that similarity search on our data, right? So it found 11 similar chunks. Ahmed and Saad are doing a workshop this today, right? So it found that this was the most similar thing to my question. If I were to ask it like what Ahmed and Saad are doing today, I don't know. I think the similarity will probably go up just to bring this point home. Yeah, 58%, right? And if I were to ask something from other data, like if you go to our memory and let's look at what was in the docs PDF, right? Which was the PDF or for all of my landing page here on the blog. We got like 9 chunks inside of this doc PDF. So it has the description here from this particular top section, right? And then it has a bunch of other description or whatnot in there, right? What's happening here is there's a chunk size here in characters. So every 1,000 characters are going to be chunked, and then there's a chunk overlap. So there at the towards the end of this particular chunk, about 256 characters will also appear in the second chunk. So if there was an answer at the very end of this, it should probably be able to answer that question from here or here, right? What we are going to do now is we are going to, run this similarity search, and at what we are going to get back are chunks of text that are relevant to our search, right? Which again we can do here as well, just to prove a point. Like for example, let's say let's ask a question about um, I don't know. Let's ask a question about shades of purple, right? Uh, Tell me about shades of purple blog post. I wonder if it is actually in that data. Shades of purple. There you go. Shades of purple themes. Celebrating over 3 million developers using shades of purple code theme. Right now that I have this chunk and the chunk below that, if I throw like 3 to 5 of these chunks into the context of an agent and asked a question, it should be able to generate answer based on all of these, right? And that is, the last step of generation. So retrieval, augmentation, and generation, right? So let's try and go ahead and let's do that, right? Let's create an agent. Let me create an agent from the code, right? So uh, ta-da-da, ta-da. So we've created the memory, we have uploaded the data, I've shown you the retrieval. Let's see what the retrieval step looks like in our code, right? So for that, we have a memory retrieve file. In that, what we are doing is, so langbase.memories.retrieve. Here's the question, what is ML doing today? And I'm adding the date. You can programmatically add the date for something like this. And I'm giving it the memory. The name of our memory was demo, I think, right? So yeah. And this will return chunks, memory chunks. Let's see what this looks like. So memory and retrieve. So now it is asking that question from this particular memory. This question was embedded and similarity search ran on the embeddings of this question and everything in this memory, and we got back these results. Let me show you all these results, right? So we are getting back about, I think, 10 memory results by default. So this was the most relevant chunk. This is, we got back an array. Here's a chunk, right? This is coming from the doc, which is called notes.md. The category is notes. This is the relevant chunks text. And it is about like 50%. It has 50% similarity. And there are, other chunks here as well, right? So I think there are 10 chunks. If I were to go back to our memory, go to the settings, you will see that by default, we have like top K3 results returning here. I can actually reduce this number to 1 or improve it to 10. I generally go with 10 because then we get the most relevant results. Most of the time, 10 is the best number to go with. And that is the number of chunks we are going to get back here, right? So about 10 chunks here, right? Now that we have gotten the results from all of this, give me a minute. What is the next step? So we've created the memory, we have uploaded the data was indexed, we sent a query, our query was embedded. On embeddings, we ran the similarity search and we got back the relevant chunks. Now, all that's left to do is we need to create an agent which will have an LLM. We will throw all these chunks in the question in that agent and it will start responding to our questions. So let's start doing that, right? So let's create an agent. So there's a file agent create. We generally call agents pipes. Pipes are serverless AI agents that live online. You can think of them like React components or Docker containers, right? And let's go ahead and create a demo agent. So this is our RAG memory agent. RAG, let's call it pipe agent demo, right? So this is an agent which will answer questions about our RAG memory data, right? So description could be anything here, right? And let's create this agent. I'm going to run npx tsx agent create, and this agent will be created. There you go, right? And right now it's showing the API key, which I will go ahead and rotate right after this particular call, but workshop. But this agent was created, and I can actually show you this in the studio. If I went to the pipe section, you will see that this was created. I'm probably going to quickly go ahead and regenerate the key. So here's the regenerated key, regenerate and copy. There you go. So that key that you people just saw is now gone, right? So yeah, so this agent was created, right? And you can configure all of this in your docs. Like for example, if I were to go into our docs and from here, in SDK, in pipe, create, you can read about all the options that you can specify, the status, the value, stream, or whatnot. If you want to specify a model or all of the fun stuff here, like I just basically created the simplest possible example of creating an agent, but you can define a bunch of stuff here. You can define the memory that is already attached here if you wanted to, right? Or you can come here, you can modify all of this. So you can modify and choose any of the top 267 LLMs that we integrate with. Our API never really changes. Our API is pretty simple, very similar to OpenAI, right? So you basically do a language pipe.run. So you're going to run an agent and you send it a message, and that message gets a response back. For example, if I were to send hey, hello, right? And if I were to run this as a demo, it will probably respond back. Uh, oh, my key. Yeah, I just probably changed the key. I need to reload this to make sure that works. But give me a minute. There you go. Yeah. Hey, hello. Right. And I'm going to run this. There you go. Hello, how can I assist you today? Right. So all of this fun stuff. So now what we're going to do is I'm going to probably change some data here, right? You're a helpful AI assistant, or let's say agent. You have access to some docs from my blog and some of my notes. Please use them to answer the questions, or say, hmm, I'm not sure, right? And now if I were to ask it a question like, like right now, this is an agent. It doesn't have access to your memory. It's just using GPT-4 or Mini, right? And if I were to ask it the same question, that what is Ahmed doing today? It will not be able to answer that question. It says, I'm not sure, right? So I'm probably gonna deploy this to production, right? And I can also, probably change something here. You will see that, we have already created one version. If I were to change something here, it will fork that version. You can see, what is being changed or what not. Now, behind the scene, what we are going to do is we are going to give it all the context it needs to answer this question, right? So for now, for that, let's switch back to our code, right? Let's go back to our steps. We created a memory, we uploaded the data, we were able to retrieve that data, and we have created an agent. Now we need to send that data, the chunks we are getting from the retrieval, into this agent's context to generate a response. Because just like we saw right now, it was not able to answer any of those questions without this context. So for that, there's a file that I've created, which is the last file you will probably see here, which is the rag, right? So what's happening here is this. We are asking, what is Ahmed doing today? We're giving it the date, right? And then we are retrieving the answers from this memory, right? So I'm probably gonna give it the right name. This should give us back the chunks. I am just looping over those chunks in creating a string of all those chunks. And then I'm going to run this agent. This is the name of that agent. Let's call it, this is the name of the agent. Yeah, I think the name of the agent was different. Rag pipe agent demo. Yeah. So the name of the agent is this, right? And to this agent, I'm going to send a message as a user that here's the context. Use the following context to answer the questions. I'm gonna throw in all the chunks from that context, and I'm gonna throw in the query that user asked, and we will see that this will be able to answer all of this right away, right? So for now, let's take a step back. Let's first see what is happening here. I'm going to comment all of this, and I'm going to show what is happening here, right? So this question and this retrieval should get us back some chunks, right? So let's run it. npx tsx agent rag. What is Emma doing today? Search in this particular memory and give me back the chunks. So we got a bunch of chunks, as you can see here. And the most relevant is actually at the top. It was re-ranked. This particular text is what we are most interested in, right? So now that you know this, I can actually go back, comment all of this. I'm going to convert the text we got from these chunks into a string, throw it in here, and we will see that now using this context, it will be able to answer all of this question, right? So what is am I doing today? Get me the chunks, throw those chunks into a string, send that chunk data to this agent, and send the same question of what is Emma doing today, and let's see what happens, right? So I'm going to save this. I'm going to run it again. It's retrieving, sending the data, sending it to the LLM, and there you go. Emma is conducting a workshop on build AI agent, agentic RAG today on this or that. I can actually ask it something else as well. Let's ask it something like, what did Ahmed celebrate about the shades of purple code theme, right? I'm gonna save this, run it again. Again, we will get back chunks relevant to this particular query. And Ahmed celebrated that there were over 3 million developers that were now using Shades of Purple theme. And there you go, right? Uh, this is pretty fun, right? Any fun questions that come to mind, Saad, before we start wrapping this up?
I think like maybe try asking it two different questions at the same time and see.
Oh, yeah, that would be fun, you know? Okay, let's ask it. So give one liner, less wordy answers, right? And I'm gonna add the plus sign here. And question one is who is Ahmad Awais and what is his role? What is he doing today? And today is this. What else? Anything fun about him? I don't know what what is going to happen on this last one, right? So uh, these are the questions I'm gonna probably write this. Okay, so we are sending multiple needles and multiple haystacks questions, right? So who is Ahmed? What is his role? This is going to be answered from this particular doc file, which includes all of our blog, right? In this one as well. But this one is going to be answered from the notes file in our memory. But we are just telling it, well, here's the data, here's the memory I need you to ask all of these questions from, right? So let's see what happens, right? So I'm gonna run it again. Let's see what it comes up with. There you go. So Ahmed is an engineering leader. He is probably hallucinating. uh, I think I should probably might have asked like, what is my current role here? But the third answer is he's conducting a workshop on this. This is perfect, right? And he loves the color purple, uh, which since the very first day. So that's literally a fun thing about me. Well, maybe I can, do one more thing. I just thought of it, right? What if when we were uploading this data, we also told it citation, citation, and in citation I said the notes, and this could be like a URL, right? So let's go with fake url.com/notes md, right? Just so that if I get back a result from this file, I should get back a citation that I can use to show to the user where the result is actually coming from, right? So in this, I'm going to show all of the chunks. I am probably going to remove all of these questions and leave the last one, this one. So let's refresh our memory. I just uploaded that file again. I'm hoping that it will update, the citation metadata I just added, right? And now I'm going to retrieve uh, that thing. So I can probably run this retrieval from this one. Yeah. What is Emma doing? So retrieve. Oh, I think I should probably have updated it. Let's update it to, I don't know, notes update or something. Let's do another thing here. Notes update. Yep. And let's upload it again. Okay. And let's retrieve. I'm probably going to confirm that it was embedded. Just give me a minute. So showing this on the stream as well. And if I retrieve it now, yeah, I get back that same result as I was hoping. And I think I forgot to do one thing. Notes updated. Yeah, uploading it again. I feel like I'm going in the rabbit hole now. Uh, going back to see if it was uploaded. Showing this on the stream. You can see the notes updated file was uploaded, right? I'm going to probably remove this one just quickly. Okay. Okay. And now I am going to retrieve this memory. So the same question, but from a different file now. And you can see that I got back the same result. The file is different, but in the metadata, I have a citation, right? So what I can do is I can actually use this citation, right? So let's say in this rag prompt, I can probably say something like, query is this, also give the citation URL as reference. And for that, I think I need to throw in that metadata here as well. So where should I get that from? Any thoughts
I think
on
it's
that?
chunks.map. It's a chunk.
Yeah, I think probably I'll probably have to uh, 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 let's awesome. So chunks have meta property, and inside it, if you find citation, add that to the string as well, right? AI is useful for some quick things, right? Okay, let's see what it comes up with. Well, there you go, right? So if there is a citation, it will be there, right? So this is just, we are reading the citation from our memory chunks, right? So there you go. And this should put it in here. And yep, I think we should be good to go. Let's run the rag again. Okay. Uh, 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 and I'm just quickly gonna search for citation. I can already see the citation is there. I'm gonna go to the bottom, and you can see the response this time is on this date, Ahmed is doing a workshop and this and that. For reference, you can check the citation, right? So like it's actually reading that URL as the metadata from the file that we uploaded. So what just happened is this, right? I know it was a bunch of back and forth on this and that, but this is basically what just happened. Uh, I gave each file some metadata, and this could be like hundreds of files. And when I asked a question, it basically ran the similarity, it found the chunks, and in those chunks, it found that there was this notes updated file, right? And it had a citation metadata, right? So when I threw this to an LLM and asked it, oh, so what did Emma do? What is Emma doing today? All the chunks in the citation and my question, when we sent it to an agent, to an LLM, through an agent, we got back the result of, well, Emma is doing this workshop, and well, here's the URL for the citation, right? This is basically, you can create citations back to where you're getting data. And citation could be anything. It could be a system where you can show a map on top of a PDF, like this is where I'm reading this data from. Or it could be an internal reference link to something like, this is the Slack conversation I'm talking about, right? Like, for example, if you create a Slack AI agent on Langbase, and you can ask, so where did Saad mention doing this work on docs? And if we are able to find that in our memory, it will also basically link back to that particular thread. So it won't only just tell me what just happened, but would also give me back the citation URL, so I can click that and go to that exact conversation instead of just looking around that data, right? So I think we covered a lot here, right? So we've covered how to build a memory, how to build an agent. And by the way, our AI Studio can also help you do all of this. Like you can come in here and everything you see in our studio is actually behind an API. So everything here is doable on our API and SDK. In fact, we are an API first business. So our API and SDK have more things you can do, programmatically create memories and agent pipes, right? Than in our studio. But studio can also be very helpful. Like I can attach a bunch of data here. Like I can give it this particular memory and I can give it entire of Langbase documentation. I can give it my health data, and now I can ask it like who is the founder of Langbase and how tall is he in centimeter and how tall is he? Let's see what comes up, right? So let's see what is going to happen here. There you go. Founder of Langbase is Ahmad Awais, and he's 185 centimeter tall. And you can go down in these runs. You can see the cost of this last run, right? You can see, how long it took. You can see this was run in Playground. You can then jump into the details of this run. And from the details, you can see the prompt actually had some chunks in it. This was the question. And these chunks is something that we got from our memory, and there's a lot happening here, right? So Emmett started Langbase 2023 and a bunch of other stuff, and I'm sure there's somewhere here where it says how tall I am in my health data. I'm just gonna quickly search for this. There you go. Emmett is this much tall, and this is coming from notes, right? And you can see the sources are being quoted here as well, right? So all of the fun stuff. And this was just an experiment. I didn't save this, as you can see. This is just a draft fork right now, and I have changed a bunch of things here, right? Uh, what you can do now is you can send this particular run to one of your teammates. This is why you would probably want to create an org on Langbase. And they can jump into Discord. They can see all of this. They can see what the question was. They can see the cost, right? They can probably click here and they will land into your experiment, right? It's like a pull request of sort into your agentic experiment, right? And they will see that these were the memories that were attached. This is the model they were you were using, and maybe they want to experiment more and save it as a sandbox. Maybe what they want to do is maybe they want to try Gemini, right? Make sure you have the LLM API keys for that. I do. So I'm going to use Gemini 2.0 Flash. I'm going to ask the same question: who is the founder of Langbase, and tell me how tall is he, right? It's probably going to quickly run this. Uh, there you go. Emma started in this. He is 185 centimeter tall. Here are the links. Let's go into the run. And what do you know? Gemini Flash 2.2 is actually cheaper from GPT-4o Mini. Run it a million times. This is $800 versus $500. You can even go with expensive models like, I don't know, Chat GPT 4. Yeah, Chat GPT 4 model. Again, ask the same question. Command K, paste, run. Chat GPT 4 model is literally the model Chat GPT uses in Chat GPT, right? So same answers, much better formatting or whatnot. Let's refresh the runs. The cost is unbelievable, right? So this was GPT-4 Mini. This was Gemini. This was ChatGPT for a model for almost the same answers. This is going to cost you about $30,000 if you run it a million times versus 500 or 800, right? So like you can easily run those experiments very, very quickly in our playground with terabytes of memory agents. And this is like agentic RAG. There are multiple memories attached right now. The reasoning behind all of this is happening completely agentically, right? It is an autonomous reasoning, re-ranking, and rewrite engine that you don't have to write. All you are doing is, oh, here are the memories. I just uploaded my data to these memories. I'm going to switch from one model to another, and I'm going to run this, and I'm going to see, what the answers look like, right? And then you can, once, over the course of this, you can save it as a sandbox if you want to experiment more or whatnot. Over the course of this, you will also see a new usage prediction happen in this particular agent, where we will be able to predict based on all the models that you are changing over time, that eventually you're going to pay something like 300 $3,588, $3,588 per million requests, because I think this particular one just caused the mess here, the ChatGPT 4 model. I was just doing this demo earlier, and if I were to look at that with where I just use inexpensive LLMs like GPT-4 or Mini, the prediction of per million is just 284 per million, right? Again, you can do all sort of this experimentation. You can go to our model, page and see all the models, why we recommend them, like why should you be using O3 Mini, what are the key features of O3 Mini, the benchmarks, the transparency, the safety layer of all of this. You can go to our explore page and explore everything people are creating and open sourcing. Like, for example, I don't know who this guy is. Like, there's so many of these, right? But if I were to just go back up, so this was Fit Buddy, right? An AI agent, which is a gym buddy that is helping you navigate your workouts. Well, that sounds pretty good, right? Let's open this up, right? And you can create agents that are open source, just like a GitHub repository that is open source. You can see this particular person went through, I don't know, 20 versions of this particular agent. I don't even know, who this is and what they're doing, but I think they've done a good job writing this complete prompt. There you go. There you go. This is pretty good. The progress bar or whatnot. I imagine they might have some runs. Let's say, what were they asking? And just my current routine. What was the completion? Well, here's your current routine. Let's start. Share this and this. What do you want to be adjusted? This is pretty fun, right? And you can build your AI profile, so you get hired or whatnot. You can see this guy has, or this person has like about 32 agents, 23 memories. He's a pro user and he's doing a bunch of stuff. I think I saw something about medicine or whatnot. I know medicine, yeah, diagnosis, doctor pulse, something like that, right? I wonder if this is no, this is not that, right? I was just seeing, I just saw something here the other day in our Explorer tab trending, which was actually doing a diagnosis of sorts. Uh, I don't know. You get the idea though. I completely forgot what the name was, right? So what we have done, to recap, we have created a pipe agent. We've created a memory agent. We have created all of this through code, and all of the code is actually open source and available on this particular link, which we are going to leave again. I'm going to probably put this in here as well, show it to you here. But basically, it's Langbase examples repository, and inside of that examples repository, you will find the RAG memory agent. We have also put all of this in our docs. So in agent examples, you will see build agentic RAG with TypeScript, and you can follow all of this guide, right? And we have also explored what it looks like to experiment and evaluate these agents based on our AI studio. And you can fork all of this, like my RAG pipe agent is public, so you can easily fork it, take it to your particular user account and go from there, right? And that's pretty much about it. That's pretty much the workshop. I'm probably quickly gonna see if we missed anything from our notes. So we created a memory, uploaded the data, retrieved relevant chunks from that data, created an agent that did the RAG, retrieval augmented generation, and we showed you the entire response. I think that's pretty much about it. What do you think, Saad?
Yeah, that's about it. Those of you who have, I think there are a few questions, but I think Saqib was answering them in the chat. However, like if you guys still have any questions later, feel free to join
let's
up.
let's let's yeah let's take those questions and answer them here as well, right? uh
Yeah, of course. I think someone was asking how to use Langbase with Next.js build AI chatbots.
yeah, so Next.js, we have a guide on that on our in our docs. Let me actually share my screen back here. So if you go to our docs, since Langbase is not creating a framework in just an SDK, you can basically use this SDK anywhere you can write TypeScript code. If you are in using some other language, you can use our HTTP API, and you can write with any language. All of this code could be in any language like Python or I don't know, Java, what have you, right? So with Next.js, if you go down here, you will see what these primitives are. You will see the agent architectures, SDK, AI agents, memory agents, and then some key guides over here, right? So, for example, maybe you want to embed all of your docs. You want to put AI in your docs. Here's an example for that. Maybe you want to handle your emails with an AI email agent. There's a complete project built for that. Maybe you want to build your own lovable V0 in bold like thing. There's a complete example for that. You can understand how RAG works, which was this workshop, and there will be more. You can see more examples. You can maybe build an internet research agent that uses the internet as a tool and researches over that. All of these examples are here, right? This one is pretty fun actually. I think this is pretty. I'm pretty sure this is like Next.js based, right? So yeah, this is Next config, right? So you can see a bunch of these examples, and we have explanation on all of these. Like, let me show you what this does. This is like your own V0. If I ask it to, I don't know, paginate a list of movies, it's gonna go ahead, understand this request, and it will create the React code for that, and it will show you in just a minute. There you go, and you can play around with this React code, right? All of this that you just saw is open source, and you can see all of the memory agents, all of the pipe agents, and things that we are using behind the scene to make these decisions, right? So like everything here is open source. We have a bunch of examples that will really help. I think we have guides where there's another one, building a video wisdom map, right? This is also pretty fun. What we have done is we have created a video wisdom agent on top of a bunch of different videos. Let's look at this one. So this is an MKBHD video on Galaxy Ring. You can basically summarize, get recommendations, or I don't know, get the main idea from this. Or you can basically just ask a question like, did he recommend this ring? You can ask that. And no, did not recommend this thing. Now I don't need to go watch this 40-minute video or whatever, however long this is, right? So again, this is also open source. You can fork it on Langbase, and you can build all sorts of fun stuff, right? uh, yeah, any more questions?
Yeah, I think Talha Amin, he asked, extracting chunks from memory, we still need OpenAI embeddings?
Come again.
I think he's asking, like, when we are extracting chunks from a memory, do we at that point use OpenAI embeddings or embedding models?
Yeah, we do, right? So this is what happens, right? So when data is thrown into our memory, so here's your data, right? You threw it into, uploaded it into a memory agent, right? This is going to parse your data. Maybe it's your PDF file. We need to take out text content from this, right? And then it will create chunks from that, right? So far there was no OpenAI. This is just our platform doing what it is supposed to do. And if I were to, like, let me move it here. If I were to go here in memory, in this particular memory that we had created in the settings, I can actually define default chunk size. This is right now about 1,000 characters. I generally like it to be around 10,000 characters, where we have like 3,000 words in a single chunk. That is when you have the right amount of data in a chunk. Garbage in, garbage out. Your chunks are super small, you will not get good results, right? And you uploaded the data into a memory parsed it, chunked it. So far this is just the compute we have, the service we provide you, nothing related to OpenAI. Now what's going to happen is each chunk will be sent to your embedding model of choice. Maybe you are using Cohere embedding model for multilingual data. Maybe you have data in French, Spanish, Urdu, what have you, right? For that, you will probably use Cohere embedding model that we also support. But for the basic one, you're just using OpenAI. So you should have a key for that. And this will actually create the embeddings, which are, it will embed all of this data. in we will get back the vector data. And then once you ask a question, right? So, here's my question. We will again send that question to OpenAI. We'll again get back the vector embeddings, right? In this vector, right now, these vectors are stored in our vector store. We will run a similarity search on this. And from this, we will actually get back similar chunks, right? So chunk number one, chunk number two, in these will be re-ranked based on semantic similarity. So this is not a keyword search. This is not command F into a file. This is like, tell me, what happened on this and that. In the entire sentence that you write here will have a meaning, and that meaning, the semantic meaning of that, will be searched in the semantic meaning of all of the data that you had uploaded in your memory. And now that you got those chunks, you will be able to throw them into an agent. And that agent will send that context to any of the 200 plus LLMs we have, and answer your question. So your question, when it is being converted into vector embeddings, that is when we will use the OpenAI embedding. And your data, when it is chunked, all the chunks will be converted into a vector embedding as well. That's where we will use OpenAI embedding. I hope it's clear.
Yeah, then we have another question like, how does Langbase handle privacy in using local LLMs instead of in-cloud options, that is OpenAI, Mistral, etc.? Many customers prefer having on-premise solutions and do not want to send data to the cloud.
Yeah, I have a lot of thoughts on that. I think on premise is not working as many had hoped in this space. The reason behind that is on premise is very very hard. Hosting LLMs, it can get extremely expensive. I know of a customer, they spent like $10 million to that problem, and they ended up getting Llama hosted on prem. And by the time this was done, you already had DeepSeek, and their current infra couldn't support DeepSeek, and everybody was using DeepSeek, and the results from DeepSeek were really really good. So eventually they just kind of gave up, and they were like, okay, we'll use a provider like, I don't know, Together AI, or anybody who is hosting DeepSeek and Llama or whatnot. And all of these providers actually, which is literally why I mentioned models. You can go on these models, like for example, let's go with DeepSeek, and you can see the transparency here. If you can run locally, if they are training on your data or whatnot, and go read more about it on their websites and their privacy policy as well. Basically, you probably might want to go with a vendor, uh, you know, where you can kind of agree to a particular type of privacy. Like, for example, if you pay enterprise tier $30 per month to OpenAI, they don't train on your data. If like they have different tiers like this, right? So generally, what we see is customers are okay sending this to different clouds behind an HTTPS or whatnot. We also kind of we have a security page that I would encourage you to read. Everything that happens on Langbase is encrypted both in transit and at rest. And we use industry standards and sometimes even better to audit all of this. Everything is behind an HTTPS, everything is encrypted. And most of the times, uh, I see that there's another thing, right? So you have this giant piece of data corpus, right? And only about like 20% of it is actually private, right? Generally, in grand scheme of things, and most of it is actually public, right? So even if you care a lot about your private data, which you should, maybe you can just use us for your public data, right? You can embed your docs, which are already public, and ask questions from it, right? You can embed your I don't know, research data or research papers or whatnot. Or you can embed your entire recommended blog posts in it or whatnot, right? There are ways around it. And the last thing I'll mention on top of this is, if you were to go to our memory agent, we are about to launch a bunch of different primitives, right? This is what I'm pretty excited about, right? In these primitives, what is going to happen is you will be able to only use whatever you need from this. So use our semantic parsing, use our chunking, you don't use our embedding if you don't need to, or don't use our vector store if you don't need to, right? But use us for just this kind of stuff like semantic parsing or chunking or re-rank or retrieval, right? This is what you can actually go to stateofaiagents.com. We did a huge case study and research into figuring out how people are using and building agents, how developers are choosing this versus that, right? And we figured out which providers are good in what categories. Like, for example, if you're doing some form of translation, you might get a lot better results by using Google's Gemini models, right? If you're doing something with code, Anthropic is your way to go, right? If your questions are related to multilingual questions, Cohere really succeeds on that, right? So you can do all of this fun stuff. Use our primitives that are distilled and fine tuned on all of these different researched categories that we've found over the years, processing billions of tokens, and just be able to ship very very fast, experiment very very quickly, versus being hunkered down with 14 different vendors, this database, that database, storing threads here, session here, your runtime there, in vector stores with a bunch of these different customers. You can just do a happy path with Langbase, where we become your base of operation, where we become completely based in your grounded data, and we allow your developers to quickly ship code without worrying about the infrastructure, right? So this is already happening. A bunch of amazing startups like new.email is being built on top of us, where you can just explain what you want as email template to look like, and it will just create that. There's a V0 or Lovable like startup. I can't name names, it's not launched yet, but they're building it right now, and that is completely built on top of Langbase as well. There's Liquid Web, which is a huge enterprise customer. I think about 200 million ARR or something. They're like 500 plus 464 support agents. They use Langbase to create their support chatbot that lives inside of Slack instead of Salesforce. And they see amazing accuracy. They save a lot of time on data that is already public, right? So, yeah, there you go. This was the email that got created, right? You can build all sorts of fun stuff on top of Langbase. Yeah,
I
more
think
questions.
I think there is another question. Can we expect other kinds of chunking in future? I see we do fixed chunking with OLAP.
I should probably mention something that I completely skipped. We do have this scaffolding project called Base AI, which was like a silly experiment on the side. But if you want to use Olema, you can probably use in completely locally. Even you can probably use this to use whatever you're doing locally on prem if you wanted to. There's a bunch of guides on how to configure it with Olema or whatnot. But I think what you're asking now is about different type of chunking, right? So yeah, we are launching primitives, right? I just shared that with you. In this primitives, so you will be able to use any of these primitives, right? You can use our semantic parsing or not. You can use our chunking or not, right? So you can create your own version of chunking, but then you can use the rest of the layer, right? So you don't have to use our chunking. You can send us the chunk data and still use our vector store, which is 30 to 50 times cheaper than everything else on the market. Very, very competitive. Or you don't want to do re-ranking or rewriting of your query. Our memory agents just handle that for you. Or maybe you don't want to do semantic parsing. Who loves creating ETL pipelines? I don't. That's why I built this company to help you with the grunt work, so you can ship very very quickly. You write the logic behind it, and we create the logistics. And I'm very excited about what we are about to launch, like in a couple of weeks. That will completely fix this problem. I can't talk about it right now, but man, we are super excited.
Yeah, I think that's about it.
Awesome. I was gonna say I'll probably take one more and wrap this up. This was pretty much fun. I've been, I think, talking for like an hour and a half straight. So excited to see what people build with this. Go ahead, look at our docs, look at this particular workshops content, and build something really really good. Use your code for good. This is it from me and Saad. Have a really nice weekend ahead, and let's see what you ship, what you build with Langbase. That's pretty much it. Peace. Ciao.
Awesome.
Bye.